Hi, I'm Todd Davis, Bloomsburg High School in central Pennsylvania, and I'm here to introduce a very simple concept that I use with quantum mechanics. A lot of times students will have problems understanding some concrete things about quantum mechanics. We talk about light, which you can see, Bohr's work with spectra, Heisenberg's uncertainty principle, and Schrodinger's wave function. Those are really heady topics for the honor students in the high school. So we try to relate that down to what they may be familiar with. They know about variables, equations, and graphs, so we put that in the context of them for quantum numbers, wave functions, and then probable predicted paths of electrons. But there's still a little bit of a challenge once we've gone through all that, and a lot of that has to do with deBroglie's wave-particle duality, when we try to really explain how these electrons are behaving and the idea of them moving in waves. It becomes very, very hard for them to say, how can an electron move like a wave, which they understand, and yet still work themselves around inside of a particular nucleus. So what I use is the idea of this online spirograph. The idea of explaining that students can manipulate spirograph, and we actually get out the plastics rings and let the kids do the spirograph with their pen and pencil. And then we explain, well, that's the idea of a wave motion around a nucleus. But you don't see things like that around a nucleus, we say, of course, and the kids understand the S, P, D, and F. So if you have the correct combination, in other words, the correct quantum numbers, what you're going to get is paths of electrons that are waves that look perhaps like a p electron. And the students can then understand, well, if we manipulate the combinations again, we can get what looks like a d electron. So that's how we go ahead and explain wave function with electrons.